Hello, students and friends. I am Manoj Varma back again with another question on analytical chemistry and particularly on C-13 and proton NMR spectroscopy. And I found this question from March 2019, paper variant 42, and the subject code 9701 A-levels chemistry to be particularly challenging, and then I thought of writing down a detailed answer with explanation to this question, and I hope that the students as well as the teachers will find this useful and be able to understand some deeper concepts of analytical chemistry and spectroscopy in particular. So let's start with the question. The question says that Narexane is a drug, and the structural formula for Naramaxane has been given here. And the question is that what is the number of peaks in the carbon-13 NMR spectrum of Naramaxane? So the answer is 6, but let's try to find out how the answer will be 6. For that particular reason, I have tried to explain in detail the answer. As you know, the number of carbon peaks that you will get in the spectrum depends on the number of different carbon environments. So I have drawn a line of symmetry passing through the center of this molecule, and then I have numbered the carbon atoms which are having identical environment. So the first one is the one that I have numbered here as 1. So this carbon will give one peak, this carbon will give another peak, and it appears that these two carbons are not identical because one is near to the NH2, the other is near to the CH3, but you have to understand that this bond can rotate because it's a single bond and it can rotate, and the NH2 and CH3 can interchange their positions. So in fact these two carbon environments are identical, so are these two, and this, and all these 4 carbon environments are identical. Therefore the peaks that you will get will be 1, 2, this together will be 3, this together will be 4, this one will be the 5th, and all these 4 carbons together will be the 6th. So that clearly now makes it understood that there will be 3 peaks in the carbon-13 NMR spectrum of Naramaxane. Now let's go to the second part of the question. Given the table where the chemical shifts, but this is regarding the proton NMR, CdCl3, that's the solvent, and it shows 5 peaks, and these are the chemical shifts and for the 5 peaks, and you have to fill up this table. Here they are asking for the number of protons responsible for this peak. So to solve this question, what I did was that I tried to figure out the number of equivalent protons in the structure of the Naramaxane. So as you can see that 3, 6, 9, 12, these protons are equivalent, and because of that they will give a singlet. These 2 protons are equivalent, then these 4 protons are equivalent, then these 3 protons are equivalent, and these 2 hydrogens are equivalent. And because this proton is attached to nitrogen, it will give a broad singlet. And therefore, looking at this, that which equivalent protons are missing, I could figure out that this 12 was missing from the table, and that's how I understood that here there should be 12 protons responsible for this singlet. Now as far as the number of peaks or the splitting pattern is concerned, you can see that the protons are attached to the carbon, but the next carbon is not attached to any other hydrogens. So for example, this carbon or this carbon, this carbon, this carbon, right? So these carbons, the protons attached to this carbon. So this carbon, the next carbon does not have any hydrogens attached to them, because for this carbon is attached to this carbon or this carbon, which do not have any hydrogens. So there will not be any splitting pattern, and all the signals that you will get will be singlets. And because these two protons are attached to the nitrogen, you will get a singlet for that particular, and a broad singlet for that particular proton. So I think that is clear about the answer. Now let's go to the next part of the question. And even this was a bit challenging, and but it is not that challenging if you just have already identified that these are the 12 protons, 3, 6, 9, 12, so which are giving a peak. So just see for that 12 protons what is the chemical shift. So you can easily see that for this 12 protons the delta value is 0.9, so you can directly write 0.9 for this. Then for these two, because these are two protons, so just see here what for the two protons is 1.4, so you straight away write down 1.4. Then these are the four protons, so for four protons you go back and check. For 4 protons you have 1.7, so straight away you can write down 1.7. For 3 protons, again go back and check, it's 1.2, so you write 1.2 here. And it becomes really very tricky, but if you just focus and try to figure out, you will understand that it's not that difficult. Then the last one is the 2 protons attached to the nitrogen, and when you look at it, you look at a broad singlet, and therefore the chemical shift is already shown 2.2, so I wrote down 2.2. So in fact I didn't have even to look at the data booklet. I could figure out the values simply by studying the delta values over here and identifying the number of protons. And then finally, one of the peaks in the proton NMR spectrum disappears when the sample is shaken with D2O. Identify the peak, and you would be aware that the protons which are attached to the nitrogen or the oxygens, when the substance is dissolved in D2O, then there is an exchange state which takes place between the protons and the deuterons, as shown over here. And because deuteron nuclei do not give a signal, therefore the signal disappears, or the peak disappears. So the peak that disappears is obviously the peak due to the NH2 signal. So I think you understood the entire answer to this question, and hope you enjoyed the discussion. It was a challenging question, and hope you enjoyed it as much as I did. And if you have liked my explanation and the lecture, please give it a like and comments, share it with your friends, and if possible subscribe to my channel. Thanks a lot for watching, and see you again in the next video.